Okay, if you've ever built an app, you've for sure hit that wall, right? That one task that just grinds everything to a halt, freezes your UI, and makes for a pretty terrible user experience. Well, today, we're going to talk about a really powerful way to smash right through that wall. So let's picture a scenario we've all been in. You've got a for loop, and it's chugging through a huge batch of images to resize them. Or maybe it's transforming a massive data set. And what happens? Your whole app starts to feel like it's stuck in mud. It gets sluggish, maybe it even stops responding altogether. That right there is a classic performance bottleneck, and it's exactly what we're going to fix. The root of the problem is pretty simple. A standard loop handles each item one after the other in a nice, orderly line. And look, for small jobs, that's totally fine. But when you've got a really heavy workload, that one-by-one approach is precisely what causes the slowdown. So, what do we do instead? Well, the answer comes from Apple's amazing concurrency framework, Grand Central Dispatch, or as you know it, GCD. It hands us this incredible tool built for exactly this kind of problem, Dispatch Apply. The absolute easiest way to think about it, it's like the supercharged parallel cousin of your everyday for loop. So, what is Dispatch Apply? Officially, it's a GCD function that runs a block of code a bunch of times. But the magic, the real secret sauce, is in that last part, with the potential for concurrent execution. That means, instead of going one by one, it can fire up the work on multiple things all at the same time. Seriously, if there's just one thing you remember from all of this, let it be this right here. Dispatch Apply is basically a parallel for loop. It's a beautifully simple yet incredibly powerful idea. It takes a big job and splits the work across multiple threads to get it all done way faster. All right, so how do you actually use this thing? I know the syntax might look a little weird at first glance, but I promise it's a lot more straightforward than it seems. Let's just break it down piece by piece. So there are really only 3 key parts you need to know. First up, iterations. That's just how many times you want your code block to run. Easy enough. Next, and this is the most important part, is the queue. This is where you tell GCD where to do the work. If you give it a concurrent queue, that's when you unlock all that parallel processing power. And finally, inside your code block, you get an index, which works exactly like the counter you're used to in a normal for loop. And that brings us right to the core difference, the real heart of the matter. You've got the old, familiar, one-at-a-time sequential loop on one side, and on the other, you've got the powerful, all-at-once concurrent approach of Dispatch Apply. Let's put them side by side so you can really see what's going on. A regular for loop is predictable, right? It just plods along, running everything in order, all on a single thread. Dispatch Apply, though, it can take that same huge workload and dish out the iterations to a bunch of different threads. So here's the aha moment. Imagine you're processing 100 images. Sequentially, that might lock up your UI for, say, 5 seconds. But with Dispatch Apply splitting that work across 4 cores, that same task could be done in just over a second. For anything that's CPU intensive, this is an absolute game changer. Okay, so you might be thinking, great, it's concurrent, so it just kicks off all the work in the background and my code continues on, right? That's a super common assumption, but is that actually what's happening here? And here is the crucial detail you absolutely cannot forget. While the iterations themselves run in parallel, the Dispatch Apply function call is synchronous. What does that mean? It means it blocks the current thread. It will not move on to the next line of code until every single one of those iterations is complete. So yeah, the work gets done a lot faster, but your code still waits for the whole batch to finish. Okay, now that we get how it works, let's talk about the fun part, the practical stuff. When should you actually pull this tool out of your toolbox and use it in your code? The perfect scenarios are really any tasks where the work for one item doesn't depend on another. Think about it. Applying the same filter to hundreds of photos, running really complex math calculations on a big set of numbers, or transforming huge amounts of data from one format to another. As long as each piece of work can stand on its own, it is a perfect candidate for Dispatch Apply. So let's nail this down. Dispatch Apply is not for every single loop you write. It's a specialized performance tool. If you have a simple loop that just runs over a dozen items and finishes in a blink, using this is total overkill. In fact, the overhead might even make it a tiny bit slower. You pull this tool out when you have a clear, obvious bottleneck, a repetitive, compute-heavy task that's slowing you down, and you need to throw more horsepower at the problem. And that brings us to the final thought I want to leave you with. Now that you know this tool exists, take a minute and think about your own projects. Where's that one slow loop that's been bugging you? Where could a little bit of parallelism like this make a massive difference in performance for your users?